For this section, we're learning about evaluating limits. Our learning outcomes are recognize the basic limit laws and use the limit laws to evaluate the limit of a function. So we have several different limit laws we're going to go through a little bit at a time. First two limit laws were stated earlier in this course. We saw that the limit as x approaches a of x is a, and limit as x approaches a of some constant c is c. So ignore the dog breathing behind me. Sorry about that. Evaluate each of the following limits using the basic limit results. So this one would just be just a 2, and putting in limit as x, limit of 5 as x approaches 2 is going to just be 5 because that's a constant. Okay, let's try another one of these. Limit of x as x approaches -7 is just going to be -7. Limit laws. Let f of x and g of x be defined for all x not equal to a for some open interval containing a, assuming that L and M are real numbers, such that limit of f of x as x approaches a is L, and limit of g of x as x approaches a is M. Let c be a constant, then each of the following statements holds. So if you have the limit of a sum, that's going to be the sum of their limits. If you have the limit of a difference, that's going to be the difference of their limits. Constant multiple, if you have some constant c times a function, the limit of c times that function of x as x approaches a is going to be c times the limit of f of x as x approaches a, so you can pull that c out because c is just a constant, which is going to be c times L because we previously defined the limit as x approaches a of f of x to be L. Product laws for limits. Limit as x approaches a of f of x times g of x is just going to be the product of their limits. Likewise for quotients, if we're doing division, the limit of a quotient is the quotient of their limits, as long as the limit for the denominator is not going to be 0. And power laws for limits. So if n is an integer, the limit of f of x to the n as x approaches a is going to be the limit of f of x as x approaches a. That limit then gets raised to the n power, so it's going to be the limit to the n power. Likewise, the root law would apply. Limit of the nth root of f of x as x approaches a is equal to the nth root of the limit of f of x as x approaches a, which is the nth root of the limit. For all L, if n is odd, and it's for L being positive if n is even, because we can't take the nth root where n is even of a negative number. Okay, let's apply some of these. So use the limit law to evaluate. That's going to give us the limit as x approaches -3 of 4x plus the limit as x approaches -3 of 2. So that's going to be 4 times the limit as x approaches 3 of x plus, and then our limit as x approaches, that's a -3, sorry, -3 of 2. So that's 4 times, and that 3 in there, just make it a -3 plus 2, because that's a constant, so I get -12 plus 2 is -10. Let's try this one. So we're going to be doing the limit of the stuff on top over the limit of the stuff on bottom. So here we're going to have the limit as x approaches 2 of 2x squared minus the limit as x approaches 2 of 3x plus the limit as x approaches 2 of 1 divided by the limit as x approaches 2 of x cubed plus the limit as x approaches 2 of 4. So we can play with this a little bit longer if you want to drag this out. That's 2 times the limit as x approaches 2 of x squared minus 3 times the limit as x approaches 2 of x plus, and the limit as x approaches 2 of 1 is just 1, over, and then that one I can actually plug in now. That's going to just be 2 cubed. So 8 plus the limit of 4 as x approaches 2 is just going to be 4. Okay, so what does that give us? So it's 2 times 4 minus 3 times 2 plus the 1 over 12. 2 times 4 is 8 minus 6. So 8 minus 6 is 4 plus 1 is 5. So I get 5/12. So what do you get out of that? And now we have two different kind of functions here. So we're going to take the limit of each function. We have the limit as x approaches 6 of 2x minus 1 times the limit as x approaches 6 of the square root of x plus 4. So in the first case, let me just plug this 6 in there. 2 times 6 is 12 minus 1 is 11. And then 6 plus 4 is 10, so square root of 10. And that's it. Not a satisfying answer, but it's an answer. Limits of polynomial and rational functions. By now you have probably noticed that in each of the previous examples, it has been the case that the limit of f of x as x approaches a equals f of a. And I kind of at the last part, I just went with that because it gets a little tedious. This is not always true, but it does hold for all polynomials, for any choice of a, and for all rational functions at all values of a for which the rational function is defined. So you can't have a 0 in the denominator is what it's saying. Okay, so what this is saying, limit as x approaches a of p of x is p of a, where p is a polynomial. So it's q is a polynomial, so if you have the quotient, it's going to be p of a over q of a. You can just plug it in, where q is also a polynomial. So let's try this now. This would be the limit as x approaches 3 of 2x squared minus 3x plus 1 over, over like this. Sorry about that. Let me get my magic eraser there. Limit as x approaches 3 of 5x plus 4. So what do we have there? Plug the 3 in. We're going to have 2 times 9 minus 3 times 3 is 9 plus 1 over 5 times 3 is 15 plus 4. So it's 18 minus 9 is 9 plus 1 is 10 over 15 and 4 is 19. Okay. Moving on. We have another one of these. So since that's a polynomial, we could just plug in the -2. So it's going to be 3 times -2 cubed minus 2 times -2 plus 7. So that's going to be 3 times -8 plus 4 plus 7. So it's -24 plus 11 gives us -13. Okay, there's a video that you can watch in the embedded textbook about this. And that's it for this section. Okay, hope you enjoyed.